Okay, guys, do need you listening. This is Advanced Math Unit 9 Morning Review. Write the equation for this graph. First thing you should do is label your intercepts, your x and your y. What are your x-intercepts? -3. And is it across or bounce? Across. Now, that assumes the multiplicity. We assume that our multiplicity is 1. That does mean multiplicity is odd. We're not going to use anything higher than 2. 1 or 2. So what would our multiplicity be here? 1. Okay, then there's another intercept that's 1. What's the multiplicity there? 1. And what about there? 4. And the multiplicity is 2. How do we know the multiplicity is 2? Because it bounces. You need to be writing this down. Okay, what's the y-intercept? We should always only ever have one y-intercept. 6. And it's don't ever have to worry about bouncing. It always goes right through. Okay, if they give us a y-intercept, that means we're going to definitely have an a y-intercept or a point. A parentheses x minus 3 or plus 3? Plus 3. And then x minus 1 and x minus 4. Is that correct? Which one? This one at the end? Good. Why? Because the multiplicity is 2. Now, how do I use the y-intercept to find a? Plug it in. What is this as an ordered pair? 0, 6. Now, remember, if it's not a y-intercept and they give you an ordered pair of 1, 6, you're not plugging in zeros. But this one we are. 6 equals a 3 times -1 times -4 squared. Three times -1 is -3. What's -4 times -4? Positive or negative? Positive. So now we have 16 times -3. I'm going to move my work over here. 6 equals, what does that equal? -48. A. And I'm trying to solve for a, so what do I divide both sides by? -48, and I heard it, what is it? Is my answer -8 or -1/8? -1/8. Now, is this my final answer? That's what I would put in the answer column? No. My final answer, I'm running out of room. I use this one right here. Y equals -1/8 parentheses x plus 3 and then x minus 1 and then x minus 4 quantity squared. All right, next one, number 2. Sketch and label all intercepts. Okay, you will have quite a few like this on the test. You want to make sure that you are ready. Okay, I'm going to make my graph over here since I have less room on that side. And over here I'm going to do the work for the x-intercepts. Okay, does the 2 in the front, the coefficient of 2, count as an x-intercept? No, because it's just 2. So this one here does count. What is it? Negative. And what's the multiplicity? 2. What's another intercept? -1? Yeah. Also with the multiplicity of 2? And what about the last one? 2. Does that have a multiplicity of 2? No, it does not. Which means that this is a bounce, bounce, and a cross. Do you guys agree? Okay. Y-intercept, how do we find the y-intercept? Plug in zeros for your x's. It's not just the last number because it's not in standard form. So we have 2, and then 0 plus 3 is 3 squared is 9. Do you guys agree? 0 plus 1 squared is 1, and 0 minus 2 is -2. All right, so what do we end up with? Y equals what? -36. Okay. really quick side note, if there was an x right here in front with a 2, say it wasn't just 2, it was 2x, would that add another x-intercept? It would be a 0. Remember, if your x-intercept is 0, what does that mean about your y-intercept? It's always 0. If your x-intercept is ever 0, your y-intercept has to be 0. Because you're not going to end up here and then like scooch around back that way. It doesn't work that way. Okay. So, are we ready to graph? There's one piece we're missing. Does anybody know what it is before?
High-low.
High-low. Good job. High-low or low-high or high-high, low-low. So we look at our degree. There's a 2, 2, and a power of 1. What is it? 5. So our degree, I'll put it over here, is 5, which is odd. And is it the leading coefficient positive or negative? It's positive. So what is it? Is it going any way it's going to be high, high, or low, low? No, it's going to be high, low, or low, high. Which one is it? Low, high. You guys need to know that. You did do that last year. We spent a bunch of weeks doing it this year. Low, high. Yes? Okay, so let's go ahead and plot our intercepts are -3. 1, 2, -3. Please label them. You have to make sure you label them on your test. -1, +2. And our y-intercept of -36, you do not have to tick mark all the way down. Just put it down at the bottom, -36. And we know it's at the bottom because it's negative. Okay, so we said we're going to start low and high. And where are we bouncing? On what 2 x-intercepts? These two here? Okay, so I start low. I bounce. I don't know how low I go, but I know I come back up to hit this intercept. And do I cross or bounce again? Which makes sense because I do know how low to go this time. How low do I have to go to get the -36? And then I come up, and when I hit the 2, do I cross or bounce? And are there, after I cross it, are there any more x-intercepts bringing me down? No. So do I keep at this point going up forever? So did we end up low, high like we said? Yes, please put that away. Thank you. Okay, questions? Okay, true, false. A 5th degree polynomial function will have 5 x-intercepts. False. I should have put here will always, because sometimes it could. This would be like an always, sometimes never. But if I put always, a 5th degree polynomial function will always have 5 x-intercepts. False. Could it have 5 x-intercepts? Will it always have 5 x-intercepts? No, even if the word always wasn't there, we'd still put false. Because yes, it could, but that doesn't. If I put true, that means it will always have 5 x-intercepts. And does it? Why not? We've talked about that a ton of times. What could happen? We could have bounces. The multiplicity 2 or 3. And what else could happen? Thank you. Who's saying that? Thank you. Imaginary solutions might happen as well.
Every time you have an imaginary, it's always plus or minus, right?
It's always, yes, conjugate root
You
term.
never have just one imaginary.
Correct. You can never have an odd amount of imaginary
So
solutions.
you'd always have to have 2 or 4.
Mm-hmm. Okay. A polynomial function of degree k will have k x-intercepts.
True.
That's just like this one up here. So it would be false for the same reason, right? It might have some bounces. It might have some imaginaries. Okay. A polynomial function has a factor of x minus 3 if and only if f of 3 equals 0. Do you guys understand what that's asking? No? Okay. F of 3 equals 0 is saying when x equals 3, then y equals 0. So they're saying it like this. So a polynomial function has a factor. We've talked a lot about the difference between a factor and a solution. Yes or no? According to this, what is our solution? X equals, what is a root? That's another thing we've called it. What is a root here according to all of this here? X equals 3. Do you agree a root is also an x-intercept, which this is over here? Okay, so let's come back to this. This is saying a polynomial function has a factor of x minus 3 if and only if x equals 3 is a root. Does that make more sense? Okay, and is it true? That is. This is saying it goes both ways. If x minus 3 is a factor, is x equal 3 a solution?
Yeah.
If x equals 3 is a solution, is x minus 3 a factor? Yes, that's what the if and only if does. It goes both ways. Does that make sense? Okay, so the polynomial function has a factor x minus a if and only if f of a equals 0. That means x equals a. So if I have a factor x minus a, is x equal a solution? If I have a solution x equals a, is x minus a factor? Yes or no? Yes. So understand what this piece here is saying, because I think that's the part that can get confusing. This is just saying x equals 3 and x equals a. All right? Okay, questions on A, B, C, D? Next one. A polynomial function with a degree 5 must have at least one real root. True? False? You're saying false?
Always.
But you can have 5 like imaginary.
Okay. Did you guys hear her?
Yeah.
Okay.
It has to be
If we said false, if we said that there's not one real root, that means then all 5 are what? Is that possible? You brought that up earlier. Is that possible? No. So at least do we need to have one real root? Yes, because if I have one, then how many would be imaginary? 4. I could have more than one. Could I have 2? No, because that would be 2 and 3. That wouldn't work. But could I have 3 real roots? Because that would be 3 real roots and how many imaginary? 2. So at the very least, does it need 1? True. Why? Because if I said false, then all 5 would be imaginary, and we've already talked that's not possible. They have to be even because of the plus minus when you're solving imaginary roots. Does that make sense? Whether you're using quadratic or completing the square, you're always going to have a plus or minus. All right. How many times does a 7th degree polynomial function with roots 5, -3, with the multiplicity of 2, 7, 9, and 8 plus or minus I root 6 either touch or cross the x-axis? I'll let you guys try it, count it.
4. Because I root, you don't know, it's not enough.
Okay, so you're saying this one's never going to touch the x-axis. That's going to be one of the bumps in the graph. Okay, so that's not an x-axis touch. So 1, 2, 3, 4, 5. Did I do that right? Does a bounce count as 2 touches? Does it come back and touch it again?
only touches it once.
So this is only once. So how many times? 4. Why? This one doesn't count. That was 2 of them right there. And that double root only counts as 1. So 1, 2, 3, 4. Okay. Given the polynomial function, blah, 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 write h of x as a product of linear factors. Remember, a product of linear factors just means factored form. If 2 and -1 are roots of the function, and -1 has a multiplicity of 2. We like these in the test, and you do have a few of these, or at least one, where they give you some numbers to start off with. We don't have to do too much here other than synthetic. 5, 4, 3, 2, 1, 0 is everything there. Okay? It doesn't matter which one you start with first. Which one do you want to use first, 2 or -1? 2. And what are my numbers going to be, my coefficients? 2, 3, -15, keep going, -13, 21, and 18. Now, if you had to guess numbers on your own with this one, that one would take a while, but they gave us some numbers to work with. Okay, what do we get? 2, 4, what comes next? 7? What should our last number be if they gave us this as a root? 0. Okay. 2 times 7 is, that adds up to multiplies -2. That adds up to -15.
Oh, yeah, sorry. That's
It's okay. Okay, and that multiplies to -30, which adds up to positive or -9, which multiplies to -18. Did it work? What is our goal all the time to get this down to what?
3 numbers.
Am I there yet? Okay, can I plug in 2 again? Should I even bother with it? Because it doesn't have a multiplicity of 2. If it doesn't have a multiplicity of 2, is there any way it's going to work twice? No. So what should I plug in next? -1 and continue again. 2, -2. What does that add up to? 5, -5. Can you guys keep going? Tell me what you're getting. -6. Did you guys get -6? +6. And what's -15 plus 6? -9. +9. Did it work? Now I'm down to 4, so I still have, I can use which one again? Okay, why? Please don't forget that kids always get here and like, I'm stuck, Mrs. Torres, I don't know what to do, I don't have any of the numbers, do I start guessing? No, multiplicity of 2 means it will work again. Okay. 2, -2, 3, -3, what is that? -9, +9, did it work? All right. Now, are they asking me to find the roots or to write it in factored form? Okay, so what am I going to have to do with the 2, 3, and -9? Anyone? I will double bubble, so I have to write it 2x squared plus 3x minus 9 and double bubble. She is correct. 2x and x, 3 and 3, or 9 and 1. Is it a 3 and a 3? And can you guys tell me which one's positive and which one's negative? 2x minus 3 and x what? Plus 3. Oh, sorry. And x plus 3. Does it work? Positive 6, negative 3. Okay, so now we're ready for our final answer. H of x equals 2x minus 3, x plus 3. Is that it? Is that it?
No,
These here? X minus 2 and x plus 1. Is that it? What am I missing? The squared on the plus 1? Now, kids often ask, do I have to worry about A? You do not, because it's already worked into the problem, because up here they already gave it to you, so it's already worked in there. You don't have to worry about finding A. If you were to go through and do distribution over and over on all of these, you'd eventually end up with this, and you're...
Why don't you just put A in the front and then make it equal to 18 and then put everything to 0?
Then it's just going to cancel everything out, because you've already found everything's already worked. Your A's already worked in there. It's right there. If I were to multiply everything through, 2 would be my leading coefficient, which it is here. Another way to check it is plug in 0 for everything. Negative 3 times positive 3 times negative 2 times 1. It should come out to be 18. Okay? Well, if you did it, A would just come out to be 1. All right, so yes, you could find it, but A would come out to be 1. All right, questions on this page at all? Okay, back page. Find all the zeros for this function if this is one root or one of the zeros. We've done enough of these by now. I'm hoping everyone in class knows what to do. No?
You said
We set that equal to x. Even, it doesn't matter what kind of problem it is. If they give us this as a root, should I set that equal to x? Yes. All right. X equals -1 plus 2i. What do I move over? So x plus 1 equals 2i. What do I do to both sides? X plus 1 times x plus 1 is x squared plus 2x plus equals 2 times 2 is 4, I times I is I squared, x squared plus 2x plus 1 equals what? Negative 4. Austin will be working this out with us. It's something we turn in. Equals
I squared is -1.
I squared is always -1. Yeah, you learned that in math 2, and I'm sure you did it again last year. Did you guys work with it last year?
We didn't do anything last year.
With I's? But you learned it in math 2, Janelle. Okay. All right. So what do we do with the -4? We add it over. X squared plus 2x plus 5. Is that what you guys got? Okay, what's the common mistake kids make? Oh, equals 0. I'm going to try to solve this. Should I try to solve that? No. Okay, good. Long division. Now, how do I know it's a long division problem? What are they asking me for? Are they asking me to write it in factored form or find the zeros? Find the zeros. Okay, so I know I have to use, even if they ask me to write in factored form, I need to do long division to find the other factors. Does that make sense? Okay, P of x equals, so far we have x squared plus 2x plus 5. There's more to it. We don't know what this other factor is. Why do I need to find this other factor? So I can solve it to find the zeros. Does that make sense? Okay. Long division is what you guys said, correct? So we take the x squared plus 2x plus 5 and divide it into 4x cubed minus 5x squared minus 6x minus 65. We did one like this together yesterday, I believe, off the review worksheet. All right, help me out. X squared times what is 4x cubed? 4x distribute. 4x cubed plus what? 8x squared plus 20x. A few of you guys had asked in the beginning, do we have to use long division if we know how to use synthetic? And I told you guys there will be at least one where you're forced to. This is it. You have to at least do long division on this one. You couldn't use synthetic. Okay, change our signs. Minus, minus, minus. First one's always gone. What does this add up to? Negative 13x squared minus 26x minus 65. Okay, x squared times what is negative 13? X squared? Negative 13. Okay, let's distribute. Negative 13 times x squared is negative 13x squared. Negative 13 times 2 is negative 26x. And what's negative 13 times 5? Negative 65. What do we do with all of our signs? Change, change, and change. At this point, should everything cross out? Does the remainder have to be 0? Now, I don't know if I shared it with this class. I think it was my 6th. Maybe I did to you guys as well. If you're doing this on your own on test day and you do not get a remainder of 0, and no matter how many times you try it, you can't get it to work out, should you erase everything and leave it blank and turn it in? No, even if you can't get an answer, as long as you have work and I can check your work and I can see, hey, they knew what to do, they knew they were supposed to use long division, but they messed up here, and I can give you partial credit. So if you can't get something to work, don't scribble it out, don't erase it, leave it there even though it's wrong, because I can check it and give you partial. Does that make sense? Kids often feel like, oh, I don't want her to see my mistake. No, I need to see it so I can get partial credit. All right. So this last piece here is the 4x minus 13. Now, if they asked for it in factored form, this would be my answer. But what did they ask for? Zeros. So on your answer column, let's say this was a test question. When I set that equal to 0, what do I get? 13 over 4, comma. Is that the only one I have? Okay, I heard a few of you say plus or minus, so you guys remembered it on your own. Did I put plus or minus in my work? If I had, would it have changed anything? No, because plus or minus squared is still positive. All right, so please don't forget your plus or minus. If you forget it, it's wrong. Questions on that one? No?
We don't do anything with the, besides long divided division, we don't do anything with the x squared plus 2x.
No, this was to help us get the 4x minus 13. So all of this work and all of the long division was to get us here so that we could eventually get there. Okay? All right, find all roots for this function. Hint, -7's the lower bound. Did they give us anything on this one? Yes or no? They did not, which means this is all the work that we have to do. The P over Q, the plus minus I. Cross out numbers. So I'm going to do two separate lists. I'm going to make a positive list and a negative list, only because they gave me some upper or lower bounds. Factors of 28 over factors of 1. That's really nice when that's 1 because there's less numbers. What are factors of 28 starting with 1? What is that? Oh, good. Okay, she's a step ahead. I'm going to finish labeling, then I'm going to use what you said. Okay, 1, go ahead. 2, 4, hold on, 4, 7, 14, and then 28. Yes or no? 1, -1, -2, -4, -7, 14, 28. I just put the negative on the outside. Now, Halea already did her plus minus I first, which probably would have been a better idea. I didn't do it first, but let's see why it would have been a better idea. Okay, how many sign changes? None. What does that mean about these lists over here? Can I cross out all the positives? Did we just cut our list in half? Yes. That means I definitely need some negatives. So we could continue doing this. Is it necessary at this point if I cross out all my positives? Do you guys want to keep doing the minus I chart? Yes or no?
So we needed to find the I.
To find the number of imaginaries? Yes, so let's go ahead and continue. So f of negative x, positive or negative, x to the 4th, plus or minus 11x cubed, plus or minus 40x squared, plus or minus 58x, and plus or minus 28. How many sign changes? 4. Subtract 2, we get 2. Subtract 2, we get 0. All are negative, 2 are negative, none are negative. What are we going to have down here? If all 4 are negative, how many are imaginary if the degree is 4? 0, 2, and 4. Does that make sense? Yes. How to get these numbers down here?
No, I know how to get them. I just don't understand what to do with them.
Okay. There's not really, the only thing that we really needed on this one was this, because that allowed us to cross all this. If there's a possibility of all 4 being negative, I'm just going to keep guessing negatives until I can't go any further. That's really all we can do at this point. So we have a lower bound. What's the lower bound? So what numbers can I cross out? 14 and 28. -7 usually wouldn't work, but we can still try it later if needed. Yes?
I thought it was the lower bound. Oh, wait.
These are negatives. Yeah, if it helps, you could just put little negatives there.
Yeah,
Yeah. Okay. So we crossed out -14, -28. So we're going to start guessing numbers. 4, 3, 2, 1, 0 are all our numbers there. 1, -11. I'm going to scooch that over just a smidge. 1, -11, 40. You know what? Thank you. I'm using the wrong list. Please, please don't make that mistake. I'm not using that one anymore. Thank you. 1, +11, +40, 58, and 28. Yes or no? All right. I'm going to have you guys starting to guess numbers. Please throw out if you -1. Okay, which one doesn't work?
-1 and 2 work.
-1 and -2.
Okay, I heard a lot of work. So give me -1 and -2. Okay, so 1, -1, is that 10? -10, what does that give me? -30, what does that give me? negative 28, and is that 0? Stop here or keep going? Do I start over with the original list or with this list right here? And somebody else said negative 2 worked? Okay, so let's drop 1. What does that give me? Negative 2. 8, negative 16. What does that give me? 14 positive, and then negative 28. Does it work? All right, what do I do with this? 1x squared plus 8x plus 14. Are they asking us to write it in factored form or find the roots? Please pay attention to that. Sometimes I'll ask for roots and kids give me factored form. Or I ask for factored form and they give me roots. I will mark it wrong even if your answers are correct for what you were trying to do. Make sure you're paying attention. All right, does this factor? Does it? 7 and 2, 1 and 14. Okay, so if it doesn't factor, what do we do?
A negative b plus 1.
You're kidding. You're serious?
Okay, guys, a few things. You will have some that come out imaginary. I don't know that this one does. If it doesn't, no, you do have some. So I heard complete the square or quadratic. Does it matter which method you use? No, in this case it doesn't matter because that middle number is even. Pick whatever you are more comfortable with. What are you guys more comfortable with? Complete the square? Quadratic? Okay, so you do what you're more comfortable with. What was that? Okay, so let me show you complete the square. So I would move the 14 over. X squared plus 8x plus blank equals negative 14 plus blank. 8 cut in half squared is what? 16. And then I factor x plus what quantity squared? 4. And then what is this? 2. So it's not going to be an imaginary solution here, but remember, it could happen. Square root both sides. X plus, is that a 4? Plus 4 equals plus or minus, don't forget that, root 2. What do I subtract?
4.
X equals negative 4 plus or minus root 2. Did anybody use quadratic? Still working? Okay, so if you wanted to use quadratic, Jessica, you're going to sing it for us?
Sure. X equals negative b plus or minus square root of b squared minus 4ac all over 2a.
Good job, ladies. Thank you. All right. Yes? So x equals negative b. I'm right here. What's the opposite of b? Plus or minus the square root of 64 minus 4ac. What's a and what's c? 1 and 14. All over 2 times 1. 64 minus, what's 14 times 4? What is it? 56. All over 2. You can't reduce this yet until you've simplified that. Negative 8 plus or minus, what is that? Square root of what? Square root of, oh, thank you. All over 2. And then negative 8 plus or minus, does anybody remember what the square root of 8 is? 2 root 2. Do you guys remember that? 2, 2, 2. A 2 comes out, yes or no? 2 root 2 over 2, which reduces, you can divide them both by 2. I forgot my negative. Negative 4 plus or minus root 2. Is that what we came up with? Anyone feel like they like this better? The quadratic?
Yes.
Anyone like the complete the square better? You don't like either? I personally prefer this one myself if I had to. If I only use this one if I absolutely have to, like if the middle number is odd instead of even. Okay, x equals,
But if we do it that way, you don't have to think, is it odd or even, or just go straight?
right, true. But for this one, I don't like all the reducing and simplifying, blah, blah, blah. It just bothers me. Okay, x equals, what do we have? Negative 4 plus or minus root 2. Is that all of them? How many are here, by the way? How many solutions? 2, which means I should have 2 more. And what are they? Negative 1, negative 2. Okay.
And so roots is like where it's more than 1. And then 0 is our maybe x plus 1.
No. Roots and zeros are the same thing. Yeah. When write as a product of linear factors is when you write it in the factored form with the bubbles. All right. Given the polynomial, find all possible rational roots. All possible rational roots are the p over q. What are my factors of 8? Quickly. 1. What are my factors of 4? 1, 2, and 4. So I'm going to do plus or minus my factors of 1, 2, 4, 8 over my factors of 1, 2, 4. So when I do 1, 2, 4, 8 all over 1, does that just give me 1, 2, 4, 8? Will it always work that way for the first set? Yes, because even if this was a 1, 1 would still be a factor. Okay, and then I do 1, 2, 4, 8 divided by what? So 1/2, 2 halves. Do I already have 2 halves?
Yeah.
Do you want me to just write them all and then we can reduce them at the end?
Yeah.
Okay, 1 over 2, 2 over 2, 4 over 2, and 8 over 2. And then I do them all over what? 1 over 4, 2 over 4, 4 over 4, and 8 over 4. Okay, so plus or minus 1, comma 2, comma 4, comma 8, 1/2. 2 over 2 is what? Do we have it already? 4 over 2 is? Have it? 8 over 2? Do we have it? Okay, 1/4. Do we have that one? What about 2/4? 4/4? And 8/4 is 2. All right, does that make sense? Yes? All right, last one. Given this function, which is a possible, oh, find the degree, sorry. Find the degree. Now, if it was in expanded standard form, then you just take the larger exponent. Is this standard form or factored form? So when it's factored, you do have to add. Now be careful. I see this 5, I see this 3, and I see this 1, but what's tricky about this one?
X in the front.
Is there, I already got that X in the front. This one here? Does that one count? Yeah, so be careful. It does, and here's why. Could I, let's see if this one would have worked. Could I have factored that as x minus 5 quantity squared? Yes or no? Then if I had factored it, would it have been easier to say 5, 3, and 2? Yes, but do they always write it in all factored form? Or let's pretend this didn't factor. Does this, even if it doesn't factor, does it still have a degree of 2? This little piece here. Yes. So whether it's factored and I can see the degree of 2 or it's not factored, is it still a degree of 2? Yes or no? So this piece is a degree of 2, and then 3 and 5, what's the answer? 10. Okay, how do we do this one? We're running out of time, so we'll make it quick. First off, what is my degree? 4, and is it positive or negative? So which ones can I cross out? A. Okay, y-intercept of -7, is that what you're saying? So we could cross out D. That looks like it goes down. We don't know if that's -7 or that's -7. Does anybody know what else you could do?
We could say bounce or cross.
Which means I would have to factor this. Do we have the tools to factor that? No. Can we do our plus minus I chart to figure out how many positive negatives? Okay, how many sign changes? How many? 1. I don't even have to do the rest. I have only one positive, no other way, so what's our answer? B. Why is it B? Because how many positive solutions do I have? 1. You could do the rest, but you figured it out already. There's only one positive. Does that make sense? Yes?